Hi everyone. Okay, sorry for not being here. We are going to go through a lot in 2 different videos, but I'm not giving you homework tonight. So that means I want you to take your time in these videos and make sure to try them before I do them. Pause the video before I do it to try it for yourself. If you're totally stuck on how to get started, you can see my next step. But don't just copy everything down without trying it first for yourself. Okay, so we ended 7-4 on number 9. I'm not going to get to this extent. That's kind of what we're going to start with next class, but all next class is going to be review of everything that is in these videos with a little bit of extra new stuff. Okay, but and what we did do in class together was we solved exponential equations, and we solved them 2 different ways. We solved them by changing the bases on both sides. Okay. So an example of a question like that would be like 4x is equal to 16x minus 2. So you could change both sides to be a base of 4. If you didn't do a base of 4, or couldn't change the bases on both sides, you would apply a log to both sides so that you could use your inverse operations. Okay. For inverse operations. So an example like that is if I have 4 to the x over here, but then I had something like 15x minus 2. Okay, I can't change the logs on both sides. I cannot change the base on both sides, so I would need to put a log on both sides so that I can put the exponents down. Typically, you wouldn't see an exponent like that, but you can't change the bases or can't easily figure it out. Maybe I'd put a +1 there, I don't know. But you would apply logs on both sides so that you could bring down the exponent in front. Now with logs, that's what we're going to be starting with today, is when you see a log as the beginning of your equation, how do you work with that? So here's the first type. So this, when you see log base 6 of x equals 2, I'm hoping that you're going to start to think about logs as just in terms of equivalent exponential equations. Okay, equivalent exponential equations means turning this equation into an exponential that you know how to work with. We know that for any log, if you have log base b of x equals y, you could write this as b to the y equals x, because any base to an exponent equals the argument. So we're going to take that same idea, that any base to an exponent equals the argument. So 6 to the second power equals x. So this should make sense, that I know that log base 6 of 36 equals 2, because 6 squared is 36. So I'm rewriting this log as an exponential equation. Okay, same idea. I know the base to the exponent equals the argument. Base to the exponent equals the argument. So I know that 8 equals x plus 5. So this has to be an x value of 3. And when you substituted it back in, it should make sense that 3 plus 5 is 8. And yes, log base 2 of 8 should be equal to 3. Okay, pause and try this next one. Keep in mind, same way we have to work with bases, we can't do anything with the base until we isolate it. So you need to isolate those logs. Okay, make sure to isolate first. So pause it, try it, come back. Okay, so if you did it in the correct order of isolation, you should add the 2. Divide by the 3. Now that it's isolated, we can turn it into that exponential. So base to the exponent equals the argument. 5 squared equals 4x plus 1. So 24 equals 4x, and x has to equal 6. Okay, so in that case, every single one of those, I took the log and I turned it into exponential form. Okay, sometimes it becomes just a linear equation, sometimes it becomes an exponential, sometimes it becomes a quadratic, but you're turning it into exponential or an equation with exponents. Okay, but you can't always do that. You'll see in number 2, you don't have a single number on one of the sides, so you don't have anything that can become the exponent. What you have is the same base on both sides. So if you have the same base on both sides, this works just like if I had the same base of exponents. If I had 3 to the x equals 3 to the 12th, I know x has to be 12. Or if I have 3 to the x equals 3 to the 5x minus 1, I know that x has to equal 5x minus 1, because if the bases are the same, obviously logically the exponents have to be the same. It works that same way, that when you have bases that are the same, the 3's, you need the arguments to be the same. So I need x minus 1 to be 18. Okay, so you're just setting those arguments equal to each other. So when the bases are the same, the arguments need to be the same. So x equals 19. And that should make sense, because log base 3 of 19 should equal log base 3 of 19, because they're the exact same thing. And the 19 comes from, 18, sorry, plugged that in wrong. Okay, 18, when I plug in the 19, should equal 18, since this is coming from 19 minus 1. Okay, so again, pause it, try the next one. Okay, so in this next one, you do get 4. Since the bases are the same, I can set the arguments equal. When I checked it, it made sense, so I'm good. So that is the other way you can apply a log equation. Okay, so if you have bases on both sides, I should say the same base. Bases are the same on both sides, then set arguments equal. Okay, so these are going to be the 4 ways we approach equations. If you have an exponential, it's 2 options. If it's a log, there's 2 options. You have to make sure that you do the correct one, because you will be given a whole bunch of equations all at once, and you have to pick the correct method on how you're going to solve it. Okay, so this is the end of the 7.4 notes. Once you finish this, if you want practice on these types of questions, you can go back to the homework on question 7 that I told you to skip and work on those questions before you get a copy of the 7.5 notes. Okay, and we will review everything when we're back together on Monday. Thanks. See you at the 7.5 notes.